car is moving towards an observer at 20 meters per second, and the observer is 30 meters from the side of the road and following the car. So let's just draw a little picture here. We have the observer who is 30 meters from the side of the road. There's our observer. And there's a car 50 meters down the road. Okay, so maybe somewhere around here. There's a car. Okay, and they are traveling at 20 meters per second, and since they are closing the distance, and this is important, they're closing the distance, that rate is negative 20 meters per second. Okay, and we'll call this x, and we also have here, it says how fast is observer turning in radians per second to follow the car. So they're turning to follow the car. So there's their angle of observation, which we'll call theta, and they're turning as the car is moving along this road. And we want to know the rate at which they are turning, or d theta by dt. So we need to come up with then a relationship that relates this x distance and this angle. Okay, and we're going to do that through the tan function because we have the opposite and adjacent sides to that angle. So my relationship then looks like this. Tan theta is equal to x divided by 30. Okay, so there's a relationship. This is what we need to differentiate. And when we differentiate this, we need to generate then a dx by dt, okay, and a d theta by dt. And we also need to know some quantities in here. We might need to know a theta, and we might need to know an x. Okay, so as we differentiate this then, we get secant squared theta. Since the theta is being differentiated with respect to time, the theta is an embedded variable, so that's how we generate our d theta by dt. Differentiate the x, and since x is a function of time, we generate our dx by dt by chain rule. Okay, so let's make sure that we can piece together the parts here. There's our dx by dt. Those go together. Okay, I have my d theta by dt, which I need to solve for. And I've got a secant squared theta expression, but I don't know theta here, whereas I know x. Now this isn't too much of an issue because we could always, if we know the ratio of 50 to 30, we know the shape of the triangle, so we know the theta, so we can work out the theta. So we're going to do this slightly differently in that we probably don't even need to solve for the angle, because since we have the ratio, we can probably just use the sides. So I'm going to first solve for the d theta by dt. Okay, so I'm going to make my expression d theta by dt is equal to, this is going to become cosine on this side. So it becomes cosine squared theta divided by 30 times dx by dt. I'm just going to leave that as dx by dt right now, but again, we're just going to replace that with negative 20 meters per second. Okay, so there it is. So I just need to plug in, my negative 20 here, and I need to plug in a theta here, which I could always work out. But I'm going to do it slightly differently, because since we know we're looking for cosine. Cosine is just really a ratio of the adjacent divided by hypotenuse. So if I calculate the hypotenuse here, I get 50 squared plus 30 squared. That's 3,400. I'm just going to do this in green. So 50 squared is 2,500. 30 squared is 900. So we end up with 3,400 square root meters. Okay, so that's my length. And really I can just plug that in to cosine, because I have the adjacent 30 to 3,400. I can just plug that right in as a length. Okay, so my d theta by dt is equal to the cosine squared. So I'm just going to put my 1 over 30 here. My cosine squared is going to be 30 over 3400 square root squared. So there's my cosine squared. And then plug in my known negative 20 meters per second. Okay? And so when I work this out, the 30, one of the 30s cancels out, so I end up with negative 60. So 30 times 20 is negative 600, and 3400 square root squared is 3400. And so when I work this out, to simplify this, that becomes, well, let's see here, it's going to be negative 60 over 340. Negative 6 over 34, and we can simplify that to negative 3 over 17 radians per second. Okay, so there's the d theta by dt. So what's happening is that this angle is being reduced by negative 3 over 17 radians per second as this car moves along the road and as this observer is changing the angle at which they're observing that car.